Hello guys! It's me again, Teacher Agnes, and welcome to my Sipnayan tutorial. And for this video, still on the most essential learning competencies for Mathematics 10, Quarter 1, Lesson 1, Generating Sequences, Part 2. Learning Competency Code M10AL-1A-1. So, this lesson will focus on identifying the first few terms of a sequence given the nth term or equation. And the number 2, determine the pattern of the given rule. Are you guys ready? Let's proceed. Let's consider the picture of this coffee bean. Do you see any pattern formed from the picture? Let's write the terms of the coffee beans, starting with 4, and then we have 6, and then 8. If the pattern continues, what will be the next term? How many coffee beans does the next term have? It's 10. So what do you think is the general or the nth term of the sequence? My answer is 2 plus 2n. My nth term of the sequence is 2 plus 2n. Why? You will answer that later as we go on through this episode. Now let's consider the sequence whose nth term is defined as a sub n equals 7n minus 4. If we are to ask to get the first 5 terms of the sequence, let's start with n equals 1. So, we have a sub 1 equals, since n is equal to 1, we have 7 times 1 minus 4. But what is 7 times 1? 7 minus 4 equals 3. So, the first term of the sequence is 3. If n is equal to 2, then we have the second term, 7 times 2 minus 4. And 7 times 2 is 14 minus 4. And 14 minus 4 will give us an answer of 10. So, 10 is our second term. So, if n is equal to 3, then we will have our third term. N equals 3, so 7 times 3 minus 4. But what is 7 times 3? 21. Minus 4, we have 17. So, our third term is 17. If n is equal to 4, then we have 7 times 4 minus 4. 7 times 4 is 28. Minus 4 will give us 24. So, the fourth term is 24. And if n is equal to 5, we have 7 times 5 minus 4. And 7 times 5 is 35, minus 4, we have 31. So, we have now the fifth term, 31, and the sequence is denoted by 3, 10, 17, 24, and 31. Okay, so going back to my answer a while ago about the coffee bean sequence, my answer is 2 plus 2n. Okay, with the following terms of the coffee bean sequence, 4, 6, 8, and 10. And to show that 2 plus 2n is the end term of the coffee bean sequence, we may list down that the terms using the previous example. So if n is equal to 1, we have 2 plus 2 times 1. And 2 times 1 is equal to 2. So we have now 2 plus 2, which is equal to 4. And 4 is our first term. Next, if n is equal to 2, then we have now 2 plus 2 times 2. And 2 times 2 is equal to 4. So we now have 2 plus 4. And 2 plus 4 is equal to 6. And 6 now is our second term. What if n is equal to 3? So a sub 3 now is equal to 2 plus 2 times 3. And 2 times 3 is equal to 6. So 2 plus 6 is equal to 8. And 8 is our third term. And if n is equal to 4, we now have 2 plus 2 times 4. But since 2 times 4 is equal to 8, then we have 2 plus 8 equals 10. So 10 is our fourth term. There you have it. A sub n, or the end term of the coffee bean sequence, is defined as 2 plus 2n. Let's consider the end term defined as 2 times the quantity n plus 1. So if n is equal to 1, we have 2 times 1 plus 1. And 1 plus 1 is equal to 2 multiplied by 2 is equal to 4. And 4 is our first term. What if n is equal to 2? So we have now 2 times the quantity 2 plus 1. And 2 plus 1 is 3. So we have 2 times 3 is equal to 6. And that is our second term. If n is equal to 3, then we have 2 times 3 plus 1. 3 plus 1 is equal to 4. So we now have 2 times 4. And that is equal to 8. That's our third term. If n is equal to 4, we have 2 times 4 plus 1. And 4 plus 1 is equal to 5. So we have 2 times 5 is equal to 10. That's our fourth term. And if n is equal to 5, we have 2 times 5 plus 1. 5 plus 1 equals 6. So 2 times 6 is equal to 12. And that's our fifth term. Hence, the sequence is now denoted by 4, 6, 8, 10, and 12. Let's examine the problem. Ems helps her mother in selling cassava roll, a delicacy from Barangay Baringin. From the money that her mother is giving her, she plans to save 25 pesos per week for 7 weeks. Form a sequence that will show the amount of money she is saving from the 1st to 7th week. So on its first week, she saved 25 pesos. And for the second week, 50 pesos. And on the third week, 75 pesos. Fourth week, 100 pesos. Fifth week, 125 pesos. For the sixth week, 150 pesos. And for the 7th week, 175 pesos. Let's try to answer this next problem. The increase in the population of Kawayan City follows a pattern. That is, 1% of its previous year's population is added to the present to obtain the next. If the current population of Kawayan City is 130,000, list the city's population for the next 3 years. So to list the population for the next 3 years, we have 130,000. This is the population of Kawayan City year 2015, which is increased by 1%. Then the next year, after 2015, the population will be 131,300. And another 1% increase, we will have 132,613. And after 1% increase next year, 133,939 will be the population for the next 3 years. So what is a sequence? A sequence is a function whose domain is a finite set of positive integers 1, 2, 3 up to n, or an infinite set 1, 2, 3 up to infinity. Each element or object in the sequence is called a term. First term, second term, third term, fourth term, and so on. A sequence having a last term is called a finite sequence, while a sequence with no last term is called an infinite sequence. Sequences may come in rule form. These are sequences stated in general or nth terms. Examples are a sub n equals 2 times the quantity n plus 1 and a sub n equals 2 plus 2n. Let's try to find the first 5 terms of the sequence given the nth term a sub n equals n plus 1. If n is equal to 1, then the first term is 1 plus 1 equals 2. So first term is 2. If n is equal to 2, we have 2 plus 1, and that is 3. So that's the second term. If n is equal to 3, then we have 3 plus 1. So that is 4. That's the third term. If n is equal to 4, we have 4 plus 1, which is equal to 5. And that's our fourth term. And if n is equal to 5, we have 5 plus 1 equals 6. And that's our fifth term. So the sequence is now denoted as 2, 3, 4, 5, and 6. Now let's have our second illustrative example. Find the first 5 terms of the sequence given the nth term a sub n equals 2n minus 1. So if n is equal to 1, we have 2 times 1 minus 1. Since 2 minus 1 is equal to 1. N is equal to 2, we have 4 minus 1. That is 3. N is equal to 3, we have 6 minus 1. And that is 5. If n is equal to 4, we have 8 minus 1. And that is 7. And if n is equal to 5, we have 10 minus 1. And that is 9. There you have it. The sequence now is 1, 3, 5, 7, 9. And for our third illustrative example, find the first 5 terms of the sequence given the nth term a sub n equals 12 minus 3n. N equals 1, so we have 12 minus 3 is equal to 9. That's our first term. If n is equal to 2, we have 12 minus 6, and that is 6. Our second term. N equals 3, 12 minus 9 equals 3. N equals 4, 12 minus 12 equals 0. And n equals 5, 12 minus 15 is negative 3. Find the first 5 terms of the sequence a sub n equals negative 2 raised to n. So we have negative 2, 4, negative 8, 16, and negative 32. Thanks for watching.